Hey, welcome back to the course. So in this section, we are going to study about preprocessor directives. So in C programming, C processor directives are used to affect compile time settings of the program. So preprocessor directives are also used to create macros, which are used as a textual replacement for numbers and other things. So preprocessor directives begin with the symbol hash. For example, hash include, hash define, hash if, hash else if, like that. So those are different types of preprocessor directives supported by the C programming language. So in all your program, you actually used these preprocessor directive. At least you actually used hash include. So hash include is one type of preprocessor directive which actually instructs the compiler to do the file inclusion, isn't it? So preprocessor directives are resolved or taken care during the preprocessing stage of compilation. So you have to remember that. And preprocessor directives, they actually direct the compiler to take certain actions during compile time. So now let's see what are the preprocessor directives supported by the C programming language. We most commonly use preprocessor directives while we write macros and when we want to do file inclusion. So if you want to write macros in your program, so then you have to use hash define. So macros are nothing but they are just textual replacement for numbers and other things, which we are going to see later. So a hash define is one type of preprocessor directive and it is used to write macros in C. And after that, hash include is another type of preprocessor directive supported by C, which is used for file inclusion. So a file may be header file or any other file. You can include standard library header file or user defined file, etc. And there are other preprocessor directives which are used for conditional compilation. So examples are hash ifdef, endif, if else, if not defined, undefined, etc. So these are used to direct the compiler about code compilation. And there are other preprocessor directives such as pragmas and error. Let's move forward. First, let's explore about macros or hash defines. So macros are written in C using hash define preprocessor directive. So macros are used for textual replacement in the code commonly used to define constants. So this is the syntax of a macro. So it should start with a preprocessor directive, hash define. This is the identifier and this is a value, and please note that there is a space between this preprocessor directive and the identifier, and there is a space between identifier and a value. For example, hash define max record 10. So here this is actually a textual replacement for this number in the program. That's it. Now let's consider one simple use case. So here is a program. So here there is a variable which is compared with a constant, isn't it? You can see that this expression is written here using a macro. And this macro is defined here, hash define minimum age 18. So during the pre-processing stage of the compilation, so this identifier will be replaced by this number by the pre-processing engine of the compiler. So but what is the advantage of using such macros? Now the one important advantage is, let's say you used this constant at several places in the program, and let's say tomorrow the minimum age changes. So let's say it becomes 20. So then if you don't use these macros, so then what you would be doing? So you'd be changing program at various places, isn't it? Suppose if this constant is used at several places, right? So, but in this case, what happens is, so you have used a textual replacement, right? By using a macro. So you have to change in only one place, that is here. So if tomorrow minimum age becomes 20, then change this to 20. That's it. So everywhere it will take effect, right? So that's one of the important use case of hash defined macros. So note that during pre-processing stage of the compilation process, macro names or identifiers are replaced by the associated values inside the program. And you should also note that this is not a variable. This is an identifier or a macro name. So this is just a textual replacement for a number. That's it. Let's proceed. So in embedded system programming, we use lots of C macros to define pin numbers, pin values, crystal speed, peripheral register addresses, memory addresses, and for various other configuration values. So these are some of the examples. And here you can see that macro names are actually written using uppercase letters, right? So that is actually a convention. So you can either use capital letters or lowercase letters. It doesn't matter actually. But we usually use capital letters, so distinguish between a variable name and a macro. Because variable names we don't write in capital letters, right? So we always use a combination of capital and small letters or something like that. So if you use all capital letters for the macros, then you can easily distinguish between a variable and a macro name. And you should also note that there is no semicolon to terminate this statement. You should not give any semicolons. And take this example here. So here crystal speed is 8 mega, right? And it is terminated with a letter UL. So UL means unsigned long. So that is allowed. So you can use those characters. So with a number to tell the compiler that this number is of type unsigned long. So compiler considers this macro as a unsigned long value. Let's move forward. So now let's learn about function like macros. To define a function like macro, use the same hash define directive, but put a pair of parentheses immediately after the macro name. So now let's see an example. So here this is a normal macro definition, and now this is actually a function like macro. So this is a macro name and this is a value. And here you can see that. So this is a function like macro because so we have used a parenthesis and that is actually one argument r, and that r is used for the expression of the value. So this is a value here, and the value contains one more macro here, that is pi value, which has to be defined before this. So let's say you want to calculate the area of a circle where the radius is given. So area of circle, so this is a variable, is equal to, so now you can make use of this macro now, area of circle, and you can pass any argument here, like another variable or any number. Now this is a C statement, right? So now this original C statement will be converted into this C statement by the preprocessor engine of the compilation. So it happens in two stages actually. First, what happens is this one. So area of circle is equal to, so this is replaced by the value. So that's why pi value multiplied by, so here you are passing radius to this, right? So r will be replaced by the radius. So pi value multiplied by radius, and after that this statement will be converted into this statement where this pi value macro will be resolved. This identifier will be replaced by its value, that is this one, right? So finally this expression actually converted into this expression by the pre-processing stage of the compilation. So whenever you are evaluating macros, you should always think in terms of replacement. For example, in this case, this macro name is replaced by its associated value, that is this one, exactly the way you have written the value. So during pre-processing, this disappears and this appears. And after that, this disappears and it will be replaced by its associated value. So that's why always you should think in terms of replacement. Let's move forward. This is very important. So this macro is poorly written and it is dangerous. You should not write a function like macro like this. Why is that? So please note that you have to be careful with macro values. So this is a macro value when you are doing some operations using multiple operands. Consider this value. So this value is a combination of operators and operands, right? So when the value is combination of operands and operators, you have to be careful. You should not write something like this. What is the solution then? So before I talk about solution, now let's see why it is bad. So we'll write one small piece of code to understand why exactly this is poorly written and how it is dangerous. So let's implement a small code. So now let's write a program to calculate area of a circle. So now let me create a variable. Let's say int area of circle. And I'm going to use function like macro. First, let me write the macro. So hash define. So let me use pi value as 3.1415. and let's consider this as a float. So you can give f or small f here to tell the compiler that this is actually float. Otherwise, compiler will treat this as a double. What you can do is, so now let's write one more macro to calculate area of a circle. So let me call it as area of circle, and this macro takes an argument. Let's call it as x. Let's write the value now. Pi value multiplied by x, isn't it? So now let's call this macro. So now let's make use of this macro and let me pass a number, let's say 2. And after that, let me print the result. So I would consider this as float. Very simple. Let's compile and run. So you got the answer 12.566. That's correct. So now what I do is, instead of passing 2 here, I pass something like this, 1 plus 1. So people may use your macro in various ways, isn't it? So you never know how user is going to use your macro. So let's say I use something like this, 1 plus 1. So answer must be same, isn't it? So the answer changes, right? So that means something is wrong with the macro, right? So what happens when we do this? There is a replacement, right? So this is replaced by this one, right? So let's do that. So and x is replaced by 1 plus 1, right? Right. So the final code looks something like this. And this is replaced by this one. So now here, this expression will be evaluated according to the precedence rule. So that's why the result what you get here is actually an error, right? So this is a wrong result. So that's what I wanted to say. Never write value like this for a macro. So you have to write something like this. So you have to use parentheses generously. So use parentheses for every operand. For example, this is one operand of this operator. So use parentheses here. Use parentheses for this, use parentheses for this, and then use one more parenthesis to hold all these other components of the value. So this is a correct method, and it's the safest method. Let's do that. So now let me get back to my original code. So here, let's use first the outer parenthesis. And after that, you should guard this individual component using their own parenthesis like this. Right. And here also, this must be guarded by its own parenthesis. Right. So this is the best way to write a macro. Let's check this. Right. You get the correct answer. So that's why best practices while writing macros in C, use meaningful macro names. It's recommended that you use uppercase letters for macro names to distinguish them from variables. Remember, macro names are not variables. They are labels or identifiers, and they don't consume any code space or RAM space during compile time or run time of the program. So those are just labels or identifiers. So make sure that parentheses surround the macro value. So while using function-like macros, or when you are using macros along with any operators, always surround the operands with parentheses. In the next lecture, I'm going to talk about conditional compilation using preprocessor directives, and I will see you in the next lecture.